This is 1976 AP Physics B exam question from the workbook published for AP Physics 2, but it's also a good question to review for AP Physics 1 as well. In this circuit shown above, the current delivered by the 9-volt battery of internal resistance 1 ohm. So this is the battery. This is the positive side. This is the negative side. And the internal resistance is 1 ohm. The current through 9 volts, so the current is 3 amps. And I'm going to choose the direction of they chose the direction of the current. It's from positive to negative, so the direction of the current is 3 amps. The power dissipated in 2 ohm resistor is 12 watt. In second resistor is 12 watts. So the power on the second one, let's do a different color. The power on the second one is equal to 12 watts. Determine the reading of the voltmeter in the diagram. The voltage is measured between these 2 points. Let's choose different color, maybe this one better. So between these 2 points. Let me call these 2 points A and B. So they ask you the voltage reading, so VAB is unknown, and that's the one that they ask you. And the voltage VAB is the same as the terminal voltage, the voltage that comes out of the battery. And because you know the current through the battery is 3 amps, some voltage is going to be dropped inside of the battery before it even comes out. So that is going to be 9 volt is the voltage of the battery without the internal resistance, but also some is going to be dropped, and the voltage that is dropped is I times R, and I is 3 and R is 1. So the voltage reading between AB is going to be 6 volt. So that was my A. For B, I'm going to choose different color. Let's choose gray. So for B, determine the resistance in resistor 2. So I know because they give me the power has the formula. Power is equal to I times R. I times V. I times V. But if I replace V with I times R, I get I squared R. And if I replace I in this formula, and if I replace I in this formula with I over R, because V is equal to I times R, Ohm's law. So if I replace I with V over R, I get V squared over R. And in this case, I'm going to use V squared over R because they ask you for resistance. So I'm going to say the power is equal to V squared over R, and the power is 12. V between AB, because they're all parallel, they have the same voltage. So the voltage between this point and this point, the voltage between this point and this point, they're all the same because it's the same point A on the top and the same point B on the bottom. So I can say V squared is VAB is 6, so that's 6 squared over R, and this is over R2. So R2 or R sub 2 is equal to 36 divided by 12 and gives me 3 ohm. So R2 is 3 ohm resistor. And for the last part, for C, they ask you to determine the resistance on R1. I know that the voltage between AB is 6 volt. The voltage between AB is 6 volt. I can figure out what the current flowing through R2. So the current through R2, so let's call this one is I2. So this is I, this is just I, this is I2, and this one we're going to call I1. Okay, so I2 is equal to VAB over R2. VAB is 6, the terminal voltage outside of the battery, and R2 is 3. That gives me 2 amps is going through 2 ohm resistor. So this current right here is 2 ohms, but original was 3 ohms. That means this one through R1 is 1 ohm. So I know that is I1 is equal to 1 amps. That is 1 amp. And they ask you to find R1. R1, again through Ohm's law, V is equal to IR. Using Ohm's law, I have V divided by I1. So V is 6, I1 is 1. That gives me 6 ohm. So the answer for C is 6 ohm.